Right, hello Algebra 2 students, and today we're going to be taking a look at kind of a second day on section 4.2. In 4.1 we talked about vertex form of a quadratic equation. On day 1 of 4.2 we talked about standard form of a quadratic equation. And today we're going to add a third form to that called intercept form of a quadratic equation. So we'll get to that today and kind of go from there. So if you take a look at it's kind of just a quick review here, a lead in for what we're going to do today. So we're going to graph the following function here that is in standard form. So if you remember correctly, what we are doing is in order to find the vertex, that means the x-coordinate is the opposite of b. So in this case, it's going to be positive 2 over 2 times a, which is also a positive 2. So the x-coordinate of my vertex is going to be 1. Okay. I then am going to plug that back into the original equation to find the corresponding y-coordinate that goes with it. And if I plug that in, 1 squared minus 2 times 1 minus 8. We do that, we end up with negative 9 as the corresponding y-coordinate. Okay, so there's the vertex. A value is sitting right in front of the x squared here. There's a positive 1 sitting there, which, right again, remember, that tells you that this is going to open up. Okay, so I know my parabola is opening up from that value. Y-intercept, one of the nice parts about standard form is if you plugged in 0 for your y-intercept, you can very quickly know that negative 8 is what you would end up with. It is your c value sitting right here at the end. Okay, if I plugged in 0 for the x's, I would end up with negative 8 as an answer. Axis of symmetry, remember the equation of the axis of symmetry is x equals, always goes through the vertex, and so the x-coordinate is 1. So x equals 1 is your axis of symmetry. That's the line that will cut the parabola in half. Domain. We've talked about this before, that we can square any number, just like we could take the absolute value of any number. So my domain is going to be all real numbers. Okay? Or if you did it in interval notation, it would be from negative infinity to positive infinity, and everything in between. Okay? The range, because this opens up, remember the range then that means you're going to have a low point. Okay? So my lowest point will be my vertex, this negative 9 right here. So my range is going to be, I'm going to put it in interval notation first, from negative 9, and then opening up, it will go to infinity. Okay? Or you could write it in inequality notation, y is greater than or equal to negative 9. Okay? And again, I don't care whether you put all real numbers or this in interval notation. I don't care whether you put inequality notation. Okay, any of these are fine by me. The only reason I'm continuing to come back to interval notation is because that is what you're going to see if you move on to pre-calculus next year. They use interval notation. Okay, so let's go ahead and let's plot this. Vertex, first of all, is at 1, negative 9. So that is right here. I have a y-intercept of 0, negative 8. So that's right there. Remember, I can always use the a value to get the first set of points from the vertex. So if I go from my vertex up 1 and over 1, that'll give me one of my points, which is the y-intercept, and then I can go over the other direction to get the other one. Okay, so there's that point. It also matches up with our line of symmetry we said was x equals 1, which is right here. Goes right down the middle of my parabola. And again, as we continue through this chapter, we will add more points to this. We'll add the x-intercepts in and how you find those. We'll talk about that. Okay, but for now, there's at least a rough sketch of what your parabola looks like. Okay, and it does match up. Notice y values are greater than or equal to negative 9. That's my lowest y value, and they go up from there. Okay, so there is kind of a quick review of the last lesson. Now, we're going to graph this a different way, okay? And so if we take a look, we're going to find the x-intercepts. And what we're going to do in this case, if you remember back, we've been doing a lot of warm-ups on factoring. We are going to factor this instead, okay? So if we factor this, I'm going to put down the two sets of parentheses here. What multiplies to give you x squared? That's x times x. And then I'm looking at what multiplies to give me a negative 8 that will add to a negative 2, which in this case, 4 times 2 will work out. And in order to get a negative 2, I need a negative 4 and a positive 2. Okay? Those numbers will add to negative 2, and they will multiply to this negative 8. Okay? So this is the factored form of that. And so now, as we start to look ahead, if we remember back to the zero product property, that says that when we take the factors here, we can set each factor equal to 0 and find what the actual solutions are, the x-intercepts. So in this case, if you set this equal to 0, you would find out that x equals 4. If you set this one equal to 0 and solved, you would find out that x equals negative 2. And what we just found are our x-intercepts. Okay? We have the point 4, 0 and the point negative 2, 0. Those are the two x-intercepts of our graph. Okay? Which, if I'm going to go through and I'm going to plot this now, let me take care of that. So at x equals 4, there's one of them. X equals negative 2, there's the other x-intercept. Okay? If you notice, the next thing that I have listed then is the vertex. We got to find the vertex. Well, in this case, we're going to use that concept of symmetry. Okay? Because if those are my x-intercepts, I know that my vertex has to be halfway between those because of the symmetric nature of a parabola. So if we notice, there's a distance of 1, 2, 3, 4, 5, 6 in between those. So if I come 1, 2, 3 units, I know halfway between at x equals 1 is where my the x-coordinate of my vertex is going to be located. And now, just like in standard form, I'm going to take that 1 and just plug it back in. Okay? Just like we did on the last slide when we were doing the last problem. Okay? So in this case, when you plug it back in, you get that same negative 9 that we were talking about. Okay? The key part, though, that I wanted you to recognize is that the x-coordinate of the vertex is right in between the actual x-intercepts, doing the idea of symmetry. Okay? It's halfway between. So now I can add my vertex here at 1, negative 9. A value, okay, you notice the A value is 1 up here. There's still an A value in front right here. That did not change in front of the factored form. There's technically a 1 that sits there. So once again, A is 1, which still tells me that this opens up. Okay. If I wanted to find the y-intercept, and let's say I did this in factored form, that means that I'm plugging in 0 for x. Okay, remember, y-intercepts are when x equals 0. So if I were to plug in 0 in for x, that means what I really have, I'm going to do it off to the side here, that means f at x would equal 0 minus 4 and 0 plus 2. Well, 0 minus 4 is just negative 4. 0 plus 2 is just positive 2. I multiply those together, and I end up with negative 8 as my y-intercept, which is exactly what we got on the previous slide when we were working in a standard form. So I know my y-intercept. When I plugged in 0 for x, I got negative 8 out for y. Okay? So I can once again plot that point. There's 0, negative 8. And again, if we use the idea of symmetry, there's a point that's symmetric on the other half of the parabola. And the axis of symmetry will still be x equals 1, right down the middle. So once again, if I put that in, notice now every point, this point is symmetric with that point, this point is symmetric with that point, everything matches up, and now we've got a few more points here to make this parabola even a little bit more accurate than what it was when we did just standard form. And I only had 3 points. So now I can go through and graph it a little bit better. And there's at least a fairly accurate graph of what's going on. Okay? So this is what's called either factored form or intercept form, and that's the form that we're taking a look at today. Okay? So here is what what we're going to call intercept form. Okay, here is your standard, or here's your general equation for intercept form, or if you'd rather call it factored form, it's the same idea. So A is still the exact same thing as it was in the other two equations. P and Q in this case are your factors. They're the zeros that you have. Okay, and we talked about vertex. How do you find it? It is, let me go back to this. It is the average of your x-intercepts, or it's halfway between. Okay, I'm going to put, it is the average of the x-intercepts, okay, which means it's halfway between. Okay, it's halfway between those x-intercepts, and that's because of the symmetry. Axis of symmetry ideas, we've already talked about that, okay? So that means in this case, your x-intercepts would be p comma 0, okay, again, whatever that value is, q comma 0. Okay? And like we talked about before, there's that idea of symmetry there that we were referring to from the previous slide, okay? So we kind of talked a lot about this on the previous slide, so I'm not going to spend too much time on it. So now if we just go straight into this, and let's say I wanted to go through and graph the important parts of this, okay? This is already in intercept form or factored form, which means if I were to set these and use the zero product property, that means this would be an x-intercept of -2. This would have an x-intercept of -4, okay? So the first thing that I have, that means that my x-intercepts, okay, right away, are -2 and -4. So if I plot those, there's one of them. There's the other one, which means the vertex of this parabola is going to have to be halfway between those, which in this one's fairly obvious. It's going to have to be -3. So now if I'm going to plug in and find the y-coordinate of my vertex, that means I'm going to substitute that -3 back in. So that means we have, if I do it in a different color, that means we've got -3 plus 2 and -3 plus 4. Well, -3 plus 2 is -1. -3 plus 4 is +1, which means when I multiply those two together, I end up with a -1 as my answer, which therefore is the corresponding y-coordinate to our vertex. -3, -1. So I'm going to add that to my graph. Okay, so I found the vertex. I've got my x-intercepts. A value in this case would once again, there's an A value sitting right out here in front. That A value is 1, which means this opens up. Okay, and these 2 points actually kind of confirm the A value. If I go from my vertex up 1 over 1, it happens to be the x-intercepts, so that works out. Axis of symmetry on this one is x equals, and again, remember it needs to be an equation, x equals, okay, not just a number, and it's always the x-coordinate of your vertex, x equals -3. So if I add that to my graph, that should split the parabola right down the middle. And sure enough, it does. It goes right through the vertex. And then the only thing left that I really need to find is the y-intercept. Okay, so if I come back down here, if I wanted to find the y-intercept, remember, that is when x equals 0. So therefore, just like I did when I was finding the y-coordinate of my vertex, I'm going to plug in 0 into the factored form instead of -3. Okay? So in this case, I would have 0 plus 2 and 0 plus 4. Well, that gives me 2. This gives me 4. And therefore, I end up with 8, a +8 as my y-intercept. So y-intercept is 0, 8. I took 0, I plugged it into the factored form, and got an answer of 8. Okay? So now if I come back to my graph then, I'm going to come up here to +8. There's another point, and again, I can use this axis of symmetry to just reflect that to the other side and just match it up. So notice this point is 1, 2, 3 units away. and therefore 1, 2, 3 units away, which means right here is another point based on the symmetry of a parabola. And now I've got 5 nice points I can sketch this in. Oops, I missed, but I'm close at least, just you can see that. And there is kind of your parabola. At least you get the idea behind that. Okay, so a little bit of everything there, all of the important features of this graph. So that means there are 3 forms of an actual quadratic equations. Okay, number 1 is standard form, which we said we can find the vertex, and we've got the y-intercept as c, and we have an a value that tells us opening up or down. Vertex form, where I can very easily find the vertex and use the a value. And then intercept form, where I've got the x-intercepts in factored form that I can find, which then will help me find the vertex and then still the a value. So intercept form in this case, notice we're coming up with 5 important points rather than just 3, which is kind of nice. For all 3 of these forms, again, a tells you whether or not, if a is positive, it opens up. If a is negative, the parabola is opening down. And then the other part that it tells you, I put a in absolute value here, meaning I don't really care about the negative versus the positive. I'm looking at the number. If the number of a, okay, is greater than 1, that means the parabola is going to be narrower. If a is less than 1, it's going to be wider. Okay, so if it's closer to 0, if a is 1/2, you have a wider parabola. A equals 1 is kind of your parent function. That's your standard opening in that case. Okay, so that's what we're comparing everything to. Anything bigger than 1 means it's narrower. Anything less than 1 means it's wider. And we ignore that the negative would tell you whether it opens up or down. Okay, so there's kind of a summary of the 3 forms of a quadratic equation, just like we had 3 forms of a linear equation that we were talking about. So then, just the last part here, just a couple of quick examples. This one, if you notice now, is in vertex form, so therefore we can very quickly go through and identify the vertex, which in this case is +1, -4. Remember, the x-coordinate always looks the opposite of what it looks like in the equation. Y-coordinate looks the same. I have an a value of -3, which means, now I'm going to add some stuff here now that we've talked officially about it. That means it opens down because it's negative, and it means it's going to be more narrow because it's 3. Okay, because of your a value being a 3, which is greater than 1. The negative means it opens down. The 3 tells you that it's a narrow parabola. So if we go through and we plot this, okay, the vertex at 1, -4, we can start with that. There's my vertex, and now I can use my a value to find a set of points. So down 3 and over 1 in each direction. Okay. Notice we already ended up with the y-intercept, so I'm not going to worry about trying to find the y-intercept. And we have, since it's opening down, there's really no other points that we're going to be able to find. Oops, I missed again. I'm not doing real well here. There we go. All right. So there is your vertex form in this case. Axis of symmetry, let me add that in just so that we would have it, just to be consistent with what we've been doing. Axis of symmetry is at x equals 1. And here it's where it goes right through the parabola. Okay? That's my line of reflection, just like we did back in Chapter 1 in geometry, if you remember back to that. All right. And now, I think this is the last example that I have. Oh, no, there's a couple of more here. One more after this. All right. So now, here is standard form. So again, we can go through and find some of the nice values. Let's start with the vertex. So again, x is opposite of b over 2a when you're in standard form. So in this case, opposite of b is 4. If I double my a value, I end up with -1, meaning -4 is the x-coordinate of my vertex. So my vertex is at -4, comma, and now I need to take that and plug it back in to find the corresponding y value. So -1/2 times -4 squared minus 4 times negative 4 plus 7 gives me a y-coordinate, looks like, of 15. Okay, so we're going to actually be off the graph here a little bit, but that's okay. I have an a value of negative 1/2, which now tells me two things. Negative means it's opening down. And then the other thing is that it's 1/2, which means it's going to be a wider parabola, okay, than normal. It's going to be wider versus narrower. I can right away very quickly find the y-intercept on this one. Okay, y-intercept, if I were to plug in 0, I end up with 7. Remember, that is your C value right up here. That's in standard form. It's nice and easy to find what the y-intercept. Axis of symmetry, we go through and take a look at that. That one is at x equals negative 4, so that it goes right through the vertex. Okay. And let's start graphing some of this stuff so that we have it. First part, at negative 4, 15. So we're, like I said, we're up here off the graph here a little bit. 3, 4. So way up here, let's see, 1, 2, 3, 4. This is 10. So if I come up here, it's going to be way up here. I'm going to approximate this. Let's say there's my vertex right up there. Just an approximate value of negative 4, 15. My a value says there it's negative 1/2. So from that, again, I'm going to have to approximate this. I would go down 1 and then over 2 in both directions. Okay, so these are going to be approximate values. Down 1 over 2 would be, let's say, right there. Down 1 over 2, let's say, would be right there. Okay. I do have a y-intercept at 7. So I can put that point in. I'm going to add in my axis of symmetry, because when I add that axis of symmetry in, I can use that as my line of reflection. So I can take this y-intercept and just match it up over here to get another point that I know is on the parabola. So it's a little bit better, more accurate sketch. So we are 1, 2, 3, 4 units away from this axis of symmetry. So 1, 2, 3, 4 units away. I know there's another point that's on this parabola. Okay? And if we were in factored form or intercept form, I could add those to it as well, and we could go from there. But in this case, we're going to leave it alone and just sketch in our parabola from there. Ooh. All right. So there's what we end up with. And you notice it's a little bit wider parabola than normal because of that 1/2. All right, last example, and then here is that one back in factored form again. Okay. We had one in vertex form, one in standard form, and here's your one in factored form. So first thing, I'm going to start with the a value on this one. A is negative 2. Again, tells you two things. Means that it opens down because it's negative. And since the number is 2, that means that it's going to be a narrower parabola. Okay? More narrow parabola. X-intercepts, let's find that right away. The x-intercepts, if you think of the zero products property here, if x equaled 3, you would have 0 as a factor, and if x equaled negative 1, you would have 0 as a factor. That then leads me to the next part, which means I can very quickly find my vertex. Okay. If my x-intercepts are at 3 and negative 1, that means halfway between those is wherever the x-coordinate of my vertex, the symmetry idea, right down the middle here, which happens to be positive 1 for my x-coordinate of my vertex. In order to find the y-coordinate that goes with it, we got to plug it back into my equation. So we end up with y equals negative 2 times 1 minus 3 times 1 plus 1. And now we evaluate to get our y-coordinate. Negative 2 times negative 2 times positive 2. And if you multiply all of those together, negative times a negative is a positive 4, times 2 gives you a positive 8, and there is your y-coordinate of your vertex. 1, 8 happens to be the vertex. Since I have my vertex, I can quickly write down my axis of symmetry, which in this case is x equals 1, goes right down the middle. And then I still need to find my y-intercept on this one. which again, remember, is when x equals 0. And just like we did with the vertex, I had to plug 1 in to find the y-coordinate. Here, I'm going to plug 0 in to find the y-coordinate. So in this case, y equals -2 times 0 minus 3 times 0 plus 1. We end up with -2 times -3 times +1. And therefore, my y-intercept, if I multiply those together, you end up with a +6 times 1. There's your y-intercept right there. 0, 6. And therefore, I can take all of this information now and go ahead and graph it. So let's start with the vertex here at 1, 8. So we are up here at 1, 8 is my vertex. I can use my a value to get a couple of points. So I can go down 2 over 1 in each direction. There's another set of points. Okay. If you notice, the y-intercept we just said was 0, 6. That also happens to be that point right there. And then I have got my x-intercepts of +3 and -1 right there. And I'm going to put my axis of symmetry right down the middle because I want you to be able to see that everything matches up nicely here. So if you take a look, 1 unit away, 1 unit away, those two are at the same distance away from your line of reflection. 2 units away, 2 units away. Everything matches up. And so now we can go through and sketch in our parabola, which is a pretty accurate sketch. We got some good points there. And there's where we're at. Okay? Hopefully this is making some sense to you. Like I said, this is kind of the summary of the different equations of your quadratics. We've got vertex form, we've got standard form, and now you've got either intercept or factored form as you're taking a look at it. So hopefully that makes some sense. Good luck with this. If you have any questions, please ask when I see you in class next, and we'll go from there. Okay? Good luck, everybody.